In this video, we will see how to predict prices of these used Corollas by finding the model that performs the best in terms of predictive accuracy. So we start the process by partitioning our data in training and validation. To do that, we would go to Analyze in JMP, and we'll click on Predictive Modeling, and then go to Make Validation column. And here we'll divide our data into 60% going to training, and 40% going to validation. And I want to be able to recreate the same analysis every time I do the resampling. So I'll set the seed. We can just type 5555 or any just number. As long as the seed is set, it will recreate the same sample every time you click on this fixed random. So now what we have is we have 40% of the sample going towards training, and that's what we'll build our model on, and then we will check how well the model performs in predicting the price of these Corollas on our validation sample. So initially we will include all the variables. So we go to Analyze Price to a dependent variable, and we move age and everything else to the independent variables or model effects, and then we take the validation and move it to the validation column. So when JMP sees its validation, the model will be built on the training, and then that model will be used to predict the dependent variable, which in this case is the price of these used cars, on the validation set, and then we will get the accuracy measures. So the way we would do model selection automatically is, instead of standard least square, we will click here and click on stepwise, and then click Run. So this is the model dialog box, where the default option is the forward selection. In forward selection, we start with just the intercept, and then we add one variable at a time with the one that is most significant or has the lowest p-value. So in this setup, JMP would first add age, since age has the lowest p-value, and then it would keep adding these variables. Now, one way to see how this process happens is that we could click on step, so it shows the model with age added. We click on step again, then it adds weight, and then it adds the fuel type, and we can keep doing this successively till the algorithm stops or finds the best model, or we could just click go, and it's going to do that all at once. So in this model that was chosen by JMP, we get as the ideal model to include age, mileage, fuel type, horsepower, doors, quarterly tax, and weight. So it excludes metallic, color, automatic, and CC. So this is the model that JMP comes up with, and in this model we can look at a set of diagnostics. What we want is that the validation R-square, which is the R-square in the validation data set, when JMP applies this model to the validation set, should be as high as possible. And we see that it is 0.7472 in this case, which is one of the highest R-squares that we have. The second thing that we need to see, look for is that we want the malus C, which is this column, the score here, to be close to the number of predictors plus 1. So in our model, we have a total of 12 predictors, and this column gives us P. So we want the P to be fairly close to our malus C. In this case, we have 9 variables, and we have 12.7, we have 12.7. So this is the model that got chosen in the last. Now in this model, even though this is a little higher, the malus C versus P, but it's close enough that we don't suspect severe underfitting. Now if the CP was very high, much higher than the number of parameters, then there would be some underfitting, and we would want to look at other models. And then the next criteria that we can look at is the Akaike information criteria, which is the AIC. And the best model should be able to minimize the AIC. And again, we see that in our chosen model, we have 102.10262 as the AIC, which again is among the lower ones. So in all, the model that it did in step 11, which is this last model, is the model that JMP says has come up with as the best model given the way we chose our data set and running on the training and validating on the validation set. So our validation R square is 0.74, and then our root mean square error in the validation set is 1701. And as we can see, this would be the lower among other alternative root mean square errors that we could get. So if we like this model and then we want this model to score our new data, then we can click on this make model, and this will take us to the modeling window with just these variables chosen. And here we can make sure that the OLS option is selected, and we click on run. And then when we do that, JMP kind of gives us the results with this new model in place. And we can kind of scroll down and see that our parameter estimates are given here, where we have fuel type, CNG, diesel, age, mileage, doors, quarterly tax. And again, the way we interpret these dummy variables is that they are with reference to the average car price. If we want to have the more conventional interpretation, we would click on response price, click on estimates, and then estimates, we click on indicator parameterization estimates. Now, this tells us that the default category is petrol. So a CNG car starts at $3,500 less than the petrol car, and so forth. So this is the algorithm that uses forward selection, where we start with just a basic model and then we keep adding variables one by one.